All right. Good morning. We are here today. I think it is April 28th, 2020. We're going to continue on working with integers, and today we're going to expand our understanding of integers to include integer division. I want to try one thing here just to share a document that I have up on my screen, so that you can see which assignment we're talking about. So you should be able to see this right now. And the assignment that goes along with what we're doing today is understanding integer division. So I want to make sure that you are clear on that. That is the one that we are looking at. And integer division is actually not that complex, but we do need to understand integers with their signs and also division in general. Okay, so we're going to start off at like we normally do with some key ideas. So one key idea in the assignment is that multiplication and division are what we call opposite operations. So opposite operations or inverse operations. And I think you know this from when you first learned how to work with numbers. When you were multiplying, you probably were taught this. So just with regular whole numbers and the set of natural numbers, you know that, for example, if you have, example 2, oh boy, need another little dose of coffee. Today's coffee is brought to you by the little gray mug again today. Okay, I think I'm ready to go now. So example number 1, when we had just regular numbers, let's say we'll make it 10 multiplied by 3 gives you 30, okay? But if we start with the answer, we can undo that multiplication sentence. We can undo it or unwrap it by applying the opposite of multiplying, which is division. And if we multiply by either of these two factors, 10 or 3, we get the other one. So 30 divided by 3 is 10. 30 divided by 3 is 10. And the same would be true if we use the other factor. 30 divided by 10 gives us 3. So that's how you can actually see multiplying and dividing being inverse operations with just regular numbers. If we extended that idea to division with integers now, we could start with something we already know. So we already know about integer multiplication. So positive 2, I'm going to keep these small so that they're easy to work with, multiplied by negative 3. By this point, I'm really, really hoping that you would know the answer to this. So again, we have two different signs. We're applying multiplication, so a positive multiplied by a negative is going to give us a negative answer. We should establish the sign first, and then we just multiply 2 times 3. If we wanted to undo this, then we could take our answer. So in a multiplication question, the answer is called a product. So we could take the product, negative 6, and if we wanted to divide it by, let's say, negative 3, the first factor, our answer would have to be the factor we started off with in our multiplication sentence. So it would be positive 2. And the good news is you actually don't need to memorize any new rules for division of integers, because the sign rules for dividing and multiplying integers are both the same. Finally, something in math that is the same, easy to memorize. And the same would be true if we started with the other factor, because every multiplication sentence actually has two division sentences that are connected to it. So -6 divided by 2 gives us -3. And again, a negative divided by a positive is also a negative. So I hope you're starting to see what happens. So we could also, and this is the way the lesson approaches it, we could also look at the inverse operations in an algebraic way. So your assignment, I'm just going to share that with you again. If you take a look at the assignment, it starts off, it's 2 pages today. 2.5 says understanding integer division. When you go to look at that, you're going to see that it has an example up at the top that throws a variable x in there. So what is that variable x all about anyway? Well, we take a look at that. You can probably guess that that's a little bit more of an algebraic way of solving things. And basically what it does is exactly what we did, but in a little bit more, the steps look a little bit different. So when it says inverse operation, that question is just asking you to solve it using multiplication. So we're actually going to use the first one, which is positive 18 divided by -2. And we want to know what that equals. But we're going to try to solve it through multiplication. So if this was true for our first example, then what we should be able to pull off is something like this. The number we start off with when we're dividing should be equal to some unknown number that we're going to call x multiplied by -2. So we can ask ourselves, what number multiplied by -2 would give us 18? What number multiplied by -2 would give us positive 18? And remember, if we don't see the sign, it's positive. I'm going to stop sharing my screen for just a second here. Get back to the page being recorded. So I've written this out a little bit here. So what number multiplied by -2 is equal to 18? And you could write this equality in a bunch of different ways, but I'm going to do it according to the example given on the assignment. What number multiplied by -2 would give us 18? Well, that number must be 9. And the sign, in order to have a positive 18 here, this 9 must be positive, because the sign rules for multiplication kick in when we're working with division. So if that's true, x is equal to positive 9. And the answer to our original question in that first example, positive 18 divided by -2, is positive 9. So the first page of the assignment uses inverse operations to be able to solve equations. So what would I like to see in your work? Well, I want to see something like this in your answers. And I want to see the solution part as well, what the actual integer is that would make the division sentence true. Okay, so write it down like this, either in x plus 9 or something like that.